Welcome to Homework Lib.
In this problem, we are calculating the average velocity for free electrons with the ideal gas energy at a given temperature. So we have our electrons and they're flying all about the place, randomly oriented, and the energy of these free electrons is just going to be 3/2 times Boltzmann's constant times the temperature. In this case, we're told that the temperature is 300 Kelvin, and so it's a simple matter of plugging in to get our energy. And I have it in terms of milli-electron volts, so 38.8 little m eV. And like some of the other problems they're going to ask us to do, to get the velocity, or the root mean square velocity, we take this, or I should say, we take our average energy and set that equal to the kinetic energy of our electrons. And so VRMS is equal to square root of 2 times EAV all over the mass, which in this case is the mass of an electron. And if you want, you can even reduce that down because of the relations that we drew up here. So if you want to plug it all in at the same time, you can. Like this. And then one trip to Wolfram Alpha later, and you get that the velocity is 1.17 times 10 to the 5 meters per second, which seems pretty quick. But the last part of the problem wants us to compare this velocity to the speed of an electron with a kinetic energy that's equal to the Fermi energy of copper, which is done in an example. So in that case, you have VF compared to our VRMS, which is 1.57 times 10 to the 6 meters per second. And in the problem it asks us to compare, which the comparison's pretty easy. Obviously, the velocity of the electrons in the Fermi, or at the Fermi level, are much faster by an order of magnitude. You see, if you compare the exponents, 5 is definitely less than 6. But the question why there could be a little trickier to parse, but if you read further in the example, you can see that the Fermi energy is actually much higher than the energy of particles at room temperature, which, if you compare here, our energy is on the order of milli-electron volts, but the Fermi energy for copper is on the order of electron volts. So again, a much higher energy, which makes sense why the velocity of the electrons would be much higher in that case.